Welcome. Today we're going to be taking a look at the Java array data structure and how we can actually work with it to use it to store information and work with it inside Java. Let's go ahead and take a look. So before we get started, we just want to do a quick review. Java, the array, is the only fixed size data structure that's built into Java itself. It holds only one type of value, and there's no import need because it's built into java.lang. So it's right there inside the very heart of the language itself. However, it's special because it's the only data structure that can hold both either primitives or objects. We have vocabulary we need to go over, and we're talking about the Java array type. So we have the subscript notation, aka the square brackets. That's the quote keyword that we have for Java when we're working with arrays. And it's the only way you can access the contents of an individual spot in an array, especially when you're talking about replacement of that. And the subscript notation is how we access all the individual array contents as well. The index is how we actually talk to those inside those square brackets. That's how we access the individual values of each spot inside the array. And the valid ranges of that range anywhere from 0 up to and including array name.length -1. And notice that .length has no parens. We'll talk about that more in just a second. We have .length, which is the public data member, which has how many slots there are in the array. And we're talking about .length, we're using human counting. So I have 5 things in the array, 1, 2, 3, 4, 5. The index, however, is from 0 to length -1, in this case 4. So again, the .length is the actual human counting style. The indices, though, start counting as 0, so keep that in mind. And then array index out of bounds exception is the error you see most often when you're talking about arrays, because you talk to a spot that's outside of the bounds of the structure, aka it's less than 0 or greater than or equal to array name.length, because those values are not available to you when you're talking about actually working with the array itself. Here we have an example of how we can declare and initialize an array and the explanation of the different points we're looking at when we're talking about array initialization. First thing we have is the type of array that we're looking at. So we have the capital T or lowercase t indicating that we can use either an object or a primitive inside that. And then the square brackets indicating that it's an array. Then we have the name of the array, whatever variable name. Of course, we use something that reflects what's actually inside it. Use good names for that, everybody. The assignment operator, aka the equal sign, and then our new keyword because we are instantiating a new object. That does go there. Then where we go back to in that type, this is the only time you'll see the int keyword after the new, because if you're making an int array, you have to have a new int keyword right there. I know, weird. And then the square brackets and how big you're gonna make that array. You must specify the length of the array inside those square brackets. You can't leave that blank. You can't decide, oh, I don't know how big it's gonna be yet. You have to give it a default size. You can change that later on and then reassign, but you have to specify the size right there. I've mentioned before that arrays are hipster. Why are they so hipster? Well, an array is an object that has no constructors, no methods of its own, and there's not a single use of parens anywhere inside it. It's not like anything else in Java. It's special and weird, and not in the best way. Array has a public data member. Data members should be private. They belong to the object. You don't share them with everybody willy-nilly. No. But an array has a public data member. .length. It's public and it's a data member. It's not a method because there's no parens, so it's got to be a data member. It's also the only use of the square brackets in Java. Other languages use square brackets all over the place, whether it's for assigning parameters. If we're talking Objective-C, the entire thing is based on square brackets. But in Java, arrays are the only place we use square brackets. There's also no keyword. The closest thing to a keyword is square brackets themselves. I know, crazy. They're fixed size, they don't change. That's kind of special. And then it's a holdover style from C and C++. This really makes a lot more sense, especially when you're looking for the idea of access, but the really cool things that happen with C and C++ style arrays, aka pointer math, we can't do in Java because we can't manipulate pointers directly. I know, so no biggie. Arrays, we replace, we don't remove. And so they're fixed in size. You can only replace values inside it with a value that's of the same type. And so when you place the array name subindex on the left-hand side of the assignment operator, aka the equal sign, to assign a value or replace what's inside that current content. So there's always something there. It's never empty. There's something there, whether it's a null, a 0, or some existing value. You're always replacing values inside that. And it doesn't give you anything back when you do that. If we're in case of using a primitive array value, that default value is the default for the data type, which is going to be 0, or false if it's a Boolean. But still, you don't need a lot of arrays of Booleans anyway. But you have a default data type, aka 0, so you want to use a better value when you're checking to see if something has been properly changed, because if you're expecting to check, oh, it's 0, I've put some, it's not there, you want to make sure you actually, when you're initializing your array or going through and working with it, that you don't just assume, oh, because it has 0, I've got the right value there. You want to make sure you're checking with what you're working on that. On objects, on the other hand, the default value for all array elements is going to be a null. So you can do a null check really easily. Oh, is it null? No? Okay, cool. We've got values in them. We're good to go. And so it makes it really easy to validate that you have actual information inside that array that you want to actually work with. When we're retrieving values out of the array, we place the array name subindex on the right-hand side of the assignment operator, aka the equal sign, to retrieve and store it into a variable from that. And that's how you access it like that. Retrieving a primitive value will give you a copy of that value that's stored there, because again, every time we're working with primitives, you always get a copy back of whatever was stored at that spot, because it's 7, it's 3, it's pi. You can just get copies out like mad. However, when we're talking about objects, we've got two things to keep in mind. The first one we want to keep in mind is strings are immutable. So if you extract a string from an array and then change it, you're actually changing and replacing a brand new object. So that string that was in the array is not the same one. So if you're talking about changing values with strings, no, it doesn't work. It doesn't cut it because strings are immutable. So every time you change it, it's a brand new thing. So don't worry about that. However, any other object where you extract from the and you talk to it, you can modify it with the dot operator and manipulate any methods on it to call any mutators or whatever, and that will change the object both there locally in that variable we've been working with, but also changes it backside in the array because you're talking to that and using the mutating methods appropriately. Strings are special though, so keep that in mind. When you want to take a look inside an array, we most often access the contents of the array via a loop. That's the main way I work with arrays all the time. We use that subscript index parameter to make both these conditions. Index must be greater than or equal to 0, and index must be less than array name.length. If on the odd chance you've made an array that has a 0 length, then index is greater than or equal to 0, and less than .length doesn't actually work, so you can't actually access anything because there's nothing there. I know, it's crazy, but don't do it. Use a standard for loop at any time you want to do replacement operations, because if you want to replace things, it makes total sense to use a for loop because you have that index, it's defined, it increments all the time, and it updates the values as you go through it, makes it really easy to work with. Remember, you can't update using a for each because you can't modify the structure, you can't replace values at all. If you want to use a for each loop, though, it's great for providing output or printing things if you want to do modification via mutator methods also. And so you don't have access to index, you can't replace anything because, again, the only way you can replace inside arrays is access to index, and a for each does not grant that to you. So make sure you don't do that. And a for each is great for the idea of just outputting information, not replacement. You get the concurrent modification exception, and that's never happy to do. So keep that and move on. Couple reminders before we end. Remember, Java strings, not an array. Other languages, they might be, but in Java, strings are not an array. You can't use square brackets anywhere on them, so don't try. It's not going to help you. And finally, array lists are not an array. Also, no subscript notations. Array lists are amazing. They've got methods. They rock. Let's use them. And arrays are dynamically sized. They're not fixed. So you have to remember to keep that in mind as well. I hope this is a helpful review of how to work with arrays in Java in 2022. Have a great day. We'll see you next time. Cheers. Bye-bye.